Hi, Geo. This is Miss Holden, and welcome to the last unit that we're going to do this year, Unit 11. So, Unit 11 is getting ready for Algebra 2 or Advanced Algebra. So, Mr. Cornell and I have put together some topics that will help you be better prepared for next year. Some things that you should already know, and we're just going to practice with those. The first thing that we're going to start with radicals. And we're going to multiply, divide them, add, subtract them. We're going to work a little bit some more on trig. And we're also going to talk about a 30, 60, 90 triangle and a 45, 45, 90 triangle. Those are called special right triangles. You'll work some more with those next year. And it's important that you know how to factor, that you're comfortable with factoring. So we're going to review some factoring and do that with some geometry type problems, and the same thing for system of equations. So those are all things that you'll be working with next year. So we're going to start off with lesson 1, which is simplifying radicals. So before we actually start talking about radicals, we're first just going to find the product of numbers. So I have these two factors, 1 times 1 or 1 squared, and that is equal to 1. And then 2 times 2 or 2 squared is equal to 4. So take a minute, pause the video, and fill in this chart of the products. And then we're going to talk about what it looks like if I'm dealing with variables, x and exponents. And then we're going to work backwards. Okay, so pause the video and try the rest of these factors right here. Okay, so then we're looking at 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, and 14 squared is 196, and then the last one, 15 squared is 225. So I'd like you to be comfortable, probably at least up to 10. What we're going to do is these numbers on the right here, these products, are called perfect squares. On the next page, we're going to take the square root of each of these numbers, and you're going to see the square root of 9 means what number times itself is 9, and the answer is 3. But first, let's just look at x. Let's look at some variables. So say I have two factors, x times x. This is really x to the first times x to the first. Now remember, when you're multiplying, think about what do you do with the exponents. And you can see my answer right here is x squared. When I'm multiplying, I add the exponents. So 1 plus 1 is 2. Okay, so continue, pause the video, and try those 4 problems that are on the rest of this page. Remember, when you're multiplying, you add the exponents. Okay, so now that you've tried those, x squared times x squared is x to the 4th. X to the 3rd times x to the 3rd is x to the 6th. X to the 4th times x to the 4th is x to the 8th, and x to the 5th times x to the 5th is x to the 10th. So what's going to happen on the next page when we do a square root, the square root of x squared means what number times itself is x squared, and that answer is going to be x. The square root of x to the 8th is going to be x to the 4th, because x to the 4th times x to the 4th is x to the 8th. Notice that these are all even numbers, and we're going to show you what happens if you have an odd number on the next page. So if you need to write anything down, just pause the video and write it down, and we will flip over to the next page. So the next page is really just the opposite of what we did on the first page. So here I have these perfect squares, and I'm going to simplify it. So these, of course, could be done in your calculator, but I do want you to feel comfortable with these perfect squares and knowing these perfect squares, because we're going to be adding, multiplying, dividing, subtracting, and simplifying radicals. And you need to know these perfect squares in order to do that. So when I say the square root of 1, I'm really saying what number times itself is 1, and that answer is 1. The square root of 4 means what number times itself is 4, and that's 2. So this is just the reverse of what was on that other page, that first page. So again, pause the video and fill in the rest of this table right here. Okay, and after you try it, we'll just peek at these answers right here. Square root of 9 is 3, because 3 times 3 is 9. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And square root of 144 is 12. These right here are called my perfect squares. It's very important that you are familiar with these and that you're comfortable with these, because we need to know these in order to simplify my radicals. Okay, so let's look at these also with variables. So if I have a perfect square of x squared, I'm saying what letter times itself is x squared, and that would be x to the first. Square root of x to the fourth is x squared, because x squared times x squared is x to the fourth. X square root of x to the sixth is x to the third. And the square root of x to the eighth is x to the fourth. Notice all you're doing is taking half of this exponent. That's the answer. And as I said before, this only works if you have an even exponent. I'll show you what to do on the next page if you have an odd exponent. So we're just going to try some that are perfect squares. And again, by my perfect squares, I'm talking about either the numbers up above or these exponents that are even. So even exponents are perfect squares, and all of these numbers are considered to be perfect squared. So if we looked at our first problem right here, and I'm going to simplify 64x squared. So the square root of 64 is a perfect square. It equals 8. The square root of x squared, that's also a perfect square. That equals x. So my answer is just 8x. Okay, square root of 2,500. Now you might not know this off the top of your head, but the square root of 25 is 5, and the square root of 100 is 10. So the square root of 2,500 is actually 50, and you could always do that in your calculator. What do I do if I have an exponent? Now, we never did anything that was this high, but all I did was take half, right? Half of 8 is 4, half of 6 is 3, half of 1,000 is 500. So my answer is 50x to the 500th power. And what if it looks like C right here? I can actually split this up into square root of 4, which is 2, and square root of x to the fourth, which is x squared. Okay, so these were all perfect squares. Now, if the number's a perfect square or an even exponent, it's nice and easy to deal with. But most of our problems will not be perfect squares. Our problems are going to be non-perfect squares. So the way you deal with a non-perfect square is you divide it up into the largest perfect square that you have, and also the remaining factor. So we're going to show you what that looks like on the other page. It's important that you write the perfect square on the left, because that's the thing that's going to get simplified. You also want to pick the largest perfect square that you can, because if you pick a smaller number, it's sort of like when I reduce a fraction and I don't pick the biggest number that I can reduce by, I wind up having to reduce it twice. So that's all that would happen. Okay, so pause the video if you need to write anything down, and we'll try the problems on the next page. All right, so over here on the right, I have my list of perfect squares so that we can refer to them. If you want to flip back, you can certainly flip back. If you want to write that list down, you can write that list down right there. But this way you have them and you're familiar with them. Now, the way that we are going to simplify these, remember when I'm doing the square root of 32, that's not a perfect square. If you were to do that in your calculator, you would get 5 point something. All right, that's an irrational number. What I do is I break it down into the largest perfect square. So 4 actually goes into 32. 4 times 8 is 32, but 4 is not the biggest perfect square. 16 is the biggest perfect square. So I break it down to the largest perfect square, 16. And now I'm saying 16 times what is 32? Or 32 divided by 16 is 2. It's important that I write this perfect square right here first, because that's what's getting simplified. We know the square root of 16 is equal to 4, and then this square root of 2 will just stay square root of 2 forever and ever. So this is simplified. If I was to do that in my calculator, I would get the exact same answer as if I did radical 32. These are equivalent. Radical 32 is actually equal to 4 radical 2. All right, so actually, if you had a multiple choice question, you could just do radical 32 in your calculator, and you could do each of the choices in your calculator to see, but we want to feel comfortable working with these radicals if it's not a multiple choice question. Okay, so look at radical 500. And if you want to pause the video, see if you can try some of these on your own. You're saying what number goes into 500, and I want the biggest number that goes into 500. Some of these I know off the top of my head. Some of them I don't know. If I don't know them, I sort of take my calculator and I would take 500 and I would start dividing by these numbers to see what goes in. You probably know that 100 goes into 500, and 100 is a perfect square, so I write that first on the left. 100 times 5 is 500. So I'm basically breaking down the 500 to the biggest perfect square times the other factor that's not a perfect square. Now, square root of 100, I write that over on the left because that's getting simplified. Radical 100 is equal to 10. Radical 5 stays radical 5. So that whole thing is my answer. And again, these are equivalent to each other. These are equal. Now this next one, C, 16 is a perfect square. It's right here. 16 is equal to 4. And I wrote that somewhere here. 16 is equal to 4. X to the third is not a perfect square. Remember, x to the fourth is a perfect square and x squared is a perfect square. Only the even numbers are perfect squares. So what I do is I break this down into the biggest even number that I can have, and that's x squared, plus the odd one that's left over. So x squared times x is x to the third. Now this x squared is a perfect square. It equals x. So the 4 that I already simplified, and now this x get written outside of the radical, and this radical x stays radical x. Okay, so why don't you take a few minutes, see if you can try some of these, pause the video, try to see if you can do any on your own, and I'll go through them with you then. Okay, so on D, we do need to recognize on D that this 3600 is a perfect square. The square root of 3600 is equal to 60. X to the fifth is an odd exponent, so I break it down into the highest even number that I can get, and then the odd one that's left over. Square root of x to the fourth is equal to x squared, and that's 60. Both of those just get written outside of the radical because they are no longer a radical. I simplified this square root of x to the fourth. The x, though, that odd one, is still underneath the radical. Okay, so again, if you haven't already, try pausing the video and see if you can do these on your own. For 48, I want the biggest perfect square I can get. So square root of 48. And I just take, if you can't see it off the top of your head, try 48 and just, obviously it's not a number bigger than 48, but 48 divided by 36. Nope, 48 divided by 25. Nope, 48 divided by 16. Yep, that works. 48 divided by 16 is 3. So I write the 16 off first on the left because that's the perfect square that's going to get simplified. And this x to the third, I break that down to x squared and x. And I lost my radical right here, so let me write in that radical for us. Okay, so this is a square root, if my pen writes. And now each of these that are perfect squares are going to get simplified. So let me highlight them for us. This is a perfect square. This is a perfect square. So those will get highlighted. The square root of 16 is 4. The square root of x squared is x. So I'm going to write 4x. The 3 and the x, those are not perfect squares. So those will stay under the radical. So it's going to be 3x. And that's my answer. That's how I simplify. All right, F is a little bit easier because I don't have any X's in there. So I'm just looking for the biggest number that goes into 125. And hopefully you got 25 times 5 is 125. and the square root of 25 equals 5. That's a perfect square, and this 5 under the radical is not a perfect square. That's going to stay 5. All right, G. If you're feeling more comfortable and you haven't already, please try and pause the video and see if you can do some of these. It's a little bit different, G and H, because I have a number that's out in front right here. So that number is actually just going to stay out in front. That 3 is going to stay in front. The 45 is going to break down to 9 times 5, and the 3 should be out here. And the x squared is a perfect square, so I don't need to break it up. Now, anything that's a perfect square, okay, I was doing that in blue. This is a perfect square. This is a perfect square. I'm going to take the square root of 9 is 3, and the square root of x squared is x. Now, what do I do, though, with the 3 that was hanging out in front? I'm going to multiply those together. So I have that 3 that was hanging out in front, and I'm going to multiply it by the 3. And also, I think I left this as, so that 5 is right there. Somehow I lost my x. Oh, there it is. All right, so I lost the x up there. And that 3 times 3 gets multiplied together. So this right here is going to be, I just lost an x right there. That's an x. Okay, so the square root of 9 is 3. The square root of x squared is x. And then 3 times 3x is 9x. So I wound up multiplying these. If you want to put parentheses in there to remind yourself to multiply, you can. This square root of 5 stays square root of 5 the whole way. Again, on H, this 2 is hanging out in front. Square root of 52 breaks down to 4 times 13. Now, you might not have known that. I just take 52 and I start dividing by 36, 25, 16, 9, 4, and I see where it goes in evenly. The only thing that goes in evenly is 4. The square root of 4 is a perfect square. It equals 2, and this 2 is hanging out in front. 2 times 2 is 4, and this 13 stays as radical 13 the whole time. So if you have a number in front, when you simplify that radical, it gets multiplied by the number out in front. 16 is a perfect square. Square root of 16 equals 4, and I multiply that by the 16 that was hanging out in front, and that equals 64. Okay, we're going to do some multiplying and dividing in this first lesson, and then we're going to leave the adding and subtraction for tomorrow's lesson. That's actually a little bit harder to do. When I'm multiplying radicals, you multiply or divide the coefficient. That's the number in front. So if these have any numbers in front, you just multiply or divide them as normally. Then you multiply or divide the number under the radical. That's called the radicand. And then you just simplify. All right, so if I'm looking at A, I have 6 times radical 6 times radical 6t. Are there any numbers in front? No, there's really just ones. 1 times 1 is going to stay 1. Multiply the number under the radical. 6 times 60 is 360. Now I need to simplify that. I need to say what times what is 360. Okay, so if you want to try these on your own, I suggest that to get a little comfortable doing these. So you can pause the video, you can try them, and then you can start it up again and see if you got them right. But I'm looking at these perfect squares. I'm looking to see what perfect square right here goes into 360. And if you guessed 36, you were right. 36 times 10 is 360. The square root of 36 is a perfect square. It equals 6. And the square root of 10 stays the square root of 10. Now, if I'm dividing, again, there's a numbers in front of this. The coefficients are just 1. 1 divided by 1 is 1. 96 divided by 4 is 24. So this is the square root of 24. Then think about how you're going to simplify that. Think about what times what is 24. And I want it to be from my perfect square list. Think about what number goes into 24. And that would be 4 times 6. I write the perfect square first. Square root of 4 times 6. Square root of 6 is square root of 24. Now the square root of 4 is a perfect square. It equals 2. The square root of 6 is not a perfect square. It's going to stay under that radical. All right, see if you can try 5 and 6 down below, although they might be a little bit trickier. Take this radical in number 5 and do radical 17 on top and radical 25 on the bottom. Because if I was to do this in my calculator, 17 divided by 25, it doesn't go in evenly. All right. So the only thing I recognize is that 25 is a perfect square. So I divide this up. Square root of 17 stays square root of 17, and square root of 25 becomes just 5 because that was the perfect square. So this is my answer right here. That's all I can do. I cannot simplify it any more than that. When I'm multiplying x times x, I get 4x squared. And the square root of 4 is equal to 2. It's a perfect square. And x squared is an even number, and that's equal to 2x. So there you go. I've simplified it. Pause the video, try 7 and 8 on the next page, and then turn it back on again to check to see if you got it right. And then I just have one more thing to do, and that's called rationalizing the denominator, which is important that you understand how to do that as well. All right, so on number 7, I finally have coefficients out in front. 4 times 6 is 24. 30 times 3 is 90. All right, so again, all I did was I multiplied the coefficients in front. So that's the 4 and the 6. And that number stays in front. It's not under a radical. And then I multiply the numbers under the radical. And that's how I got radical 90. Then all I'm going to do is I'm going to simplify. The radical 90 breaks down to 9 times 10. The 24 is hanging out in front. Radical 9 is a perfect square. It equals 3. And I multiply that 24 times that 3, and that equals 72. And the radical 10 stays radical 10, and that's my answer. Same thing works for dividing, like in number 8. 16 divided by 2 is 8, and then 20 divided by 5 is 4. Okay, so I divided these coefficients, and that was a number that's outside the radical, and then I divide these numbers under the radical, and that answer stays under the radical. Now, radical 4 happens to be a perfect square, so it equals 2. 8 times 2 is 16. All right, so the last thing for today, and we did a lot. There's no homework on this. We did today's lesson, you're going to do tomorrow's lesson, and then you're going to do a practice on this on the Delta Math. So the Delta Math, remember, has always an example that you can look at before you do it. The Delta Math also has a video that you can look at to try and figure it out as well if you need some more help. Basically, when we're working with radicals, we do not want a radical in the denominator. The denominator is a fraction. It's the bottom number in a fraction. You are not allowed to have a radical in the denominator. Okay? So check to see if you can divide the numerator and the denominator to eliminate the radical. That would be like B on this other page. Remember how I divided the 96 and the 4. Okay, so that there's a radical in the denominator, but these are divisible, so it gives me radical 24. So that's the first thing that you should do when you're trying to do these. The next thing you should do, if you cannot eliminate the radical in the denominator, you must rationalize the denominator. Now, how does that work? You multiply the numerator and the denominator by the radical in the denominator. Then you simplify the numerator and the denominator. Let me show you how that works because it's actually kind of neat. So I have 1 over radical 2. Okay, I can't divide and get rid of this radical in the denominator. So what I do is I multiply the numerator and the denominator by the radical. So I multiply top and bottom by radical 2. Now the reason I'm allowed to do this is because radical 2 over radical 2 is really just equal to 1. So you're not changing the value of this. Now 1 times radical 2 is radical 2. Radical 2 times radical 2 is, I did it right down here. So 1 times radical 2 is just 1 radical 2. Radical 2 times radical 2 is radical 4. That's a perfect square. And radical 4 equals 2. So my answer is radical 2 over 2. So let's just look at this again to make sure it makes sense. You are not allowed to have a radical in the denominator of a fraction. The way to get rid of it is you multiply the numerator and the denominator by that same exact radical. Now, you're allowed to do that because radical 2 over radical 2 is just equal to 1. Now, in the numerator, you get 1 radical 2. It's okay to have a radical in the numerator. The denominator is radical 2 times radical 2. So basically, you are creating a perfect square. Radical 2 times radical 2 is radical 4, and radical 4 gets simplified to 2. No longer have a radical in the denominator. All right, so why don't you pause it and try 10 the same way? All right, so I have this radical 5 in the denominator. So I'm going to multiply the numerator and the denominator by radical 5. Radical 7 times radical 5 is radical 35. Radical 5 times radical 5 is radical 25. Remember, I'm creating this perfect square because radical 25 equals 5. I no longer have a radical in the denominator. And that radical 35 will stay radical 35. All right, and then I just have 2 practice problems. I'd like you guys to try them. So pause the video and try them. They're dealing with radicals in geometry. We have some rectangles. Remember, the area of a rectangle is just length times width. All right, so see if you're a little stuck a little bit, you can look at this. All right, pause the video, try it, and then turn it back on and check your answers. So area of a rectangle is base times height. So basically, I'm going to take that 3 radical 2 and I'm going to multiply it by the 4 radical 6. Okay, area of a rectangle is just length times width or base times height. So I'm multiplying the base times the height. Now think back to the rule. When you're multiplying, you multiply the numbers, the coefficients. So those coefficients get multiplied, and then you multiply the number under the radical. So 3 times 4 is 12, and 2 times 6 is 12. I'll just highlight that so you can see where those answers come from, where the numbers come from. 3 times 4 is 12, and also the 2 times 6 is 12. Now this 12 is going to hang out in front, this 12 that's not a radical, and this radical 12 breaks down to 4 times 3. All right, so I already have that written for us. You need to basically say what times what is 12. 4 times 3 is 12. Now, why do I write the 4 first? Because that's the perfect square. The square root of 4 is 2, and this 3 will stay under the radical. So 12 comes here, the square root of 4 is 2, and the square root of 3 is 3. 12 times 2 is 24, and then that stays radical 3. So that's my answer right there. That is the area of that rectangle. We're going to try one more, but in the next one, I'm going to tell you what the area is, and I'm going to tell you what the length is, and you're going to try and find the width. All right, so the area is 4 radical 6. The length is 2 radical 3, and you're trying to find this width or the height. So the base or the length is 2 radical 3. So area is still base times height. You know the area. The area is 4 radical 6. You know the base is 2 radical 3. Think about how you're going to solve for the height because you're trying to find that height. Well, you're going to divide. So both sides are going to get divided by 2 radical 3 because I'm trying to get the height by itself. Now, when I do that, this cancels and I'm left with the height. And 4 divided by 2 is 2. And radical 6 divided by radical 3 is radical 2. Okay, so that's a little bit of working with these radicals in geometry, just so you can see where those numbers come from. I divide the coefficient, that number stays out in front, and I divide the numbers under the radical. That can't be simplified, so that's just your answer. Okay, so there's no homework on this. Tomorrow, the next video, we're going to be adding and subtracting radicals, and then you will try a delta math practice on that.